subset relations. Our union, our intersection, our not, and another symbol for not. This is a very important one. This is called set comprehension, and this is symmetric difference. Now, again, we're going to be using these relations. So I'm gonna quickly copy in. You know what? For your sake, we're gonna do a cut. We're gonna cut. All right, we're back. I just spent a couple of minutes copying down all the information you need to know. Pretty Boy's not actually in any of these. And so there's Goth Irrelevant, Lindsay Lohan in the Art Nerds, Plastics. You've just heard this. And then I copy down the one diagram you have to show at the beginning of any of set theory. And so now we're going to talk about the subsetting relationship, or it's not only subsets, unions and intersections give you these relations of sets. So let's start with union, which we represent by big cap. So the union, and every example, we're going to use our standard A and B Venn diagram, where we have here's A and here is B. And if we take, let's do this in black, A cup B, which represents A union B, this is all the elements in A or in B. And so if you want to know which elements those are, let me see, is this P? Yes. Want to know what elements those are? Those are exactly these elements. So anything in these areas. So it includes the intersection, it includes all of A, it includes all of B. And the example we're going to give is basically the Art Nerds union to Plastics, which is almost the entire cast, if you look here. The Art Nerds union to Plastics, Goth, Irrelevant, and Lindsay Lohan, and Queen Bee, Karen, and Fetch. So Art Nerds union to Plastics is 6 people out of 7 of the young adults in the cast of Mean Girls. So moving on to intersection. Intersection is the opposite idea, is that instead of being either or, it's an and. So why does it keep doing that? If you want to write in LaTeX, it's \cap. And this gives you precisely the intersection of the two sets. So it'd be exactly this area if you're doing A intersect B. And in this example, we have our 2 key groups, the Plastics and the Art Nerds, and you have our lovely protagonists lying in the intersection. Like any good intersection, you find them in, or any good protagonist, you find them in the intersection of very different groups, and you find them in the center of the movie posters. And so that's where you find Lindsay Lohan, is in the intersection. Now just erase some of that. There's not so much to say. There's a lot of algebraic relations between these things, but for a quick review, I think it's probably just useful for me to just say what these are. Like this is cup, this is cap, is intersection. Now we have set minus, which is one that does come up. Oh, I'm missing one. I'm missing a complement. So we'll put that in there. We have 2 forms of set minus. Now this is used less often, but it is still used. And so you would write, A set minus B. And you use this \, but as often used, you just use a minus. Both of these things mean the same thing in most cases. And this is exactly the elements of A, which are not in B. So it's exactly this area, not the intersection. So if you do the Art Nerds minus the Plastics, you get Goth and Irrelevant. And if you do the Plastics minus the Art Nerds, you actually get exactly the old Plastics before Lindsay Lohan moved into town. And somewhat similar to set minus. I mean, the key thing to know about set minus is you don't need B to be a subset of A to do this minus operation. Like when you do the Art Nerds minus the Plastics, you're removing Lindsay Lohan, But you don't have to remove these elements. I mean, these elements are already not part of the art nerds, queen bee, Karen, or fetch. And so it's not a problem at all. But soon. Now, complement is an interesting one. It's exactly all the elements that are not in a set. And so this is a unary operation. You only take one set as the input to this, and it's kind of contextual. So if you were to take this in a literal way, in a literal set theory way, all elements not in some set, you'd get something that's too big to be a set. So that doesn't work. So it only works if you have some universe. So here I've written this big box, and so has to be some universal set. And so this operation depends on what you're talking about. It's not, if you were to write it in its full generality, you should really write it A sub C/U, because the operation depends on you, but nobody does that. This is never done. Mathematics, even though we're very rigorous, means suppressing necessary details all the time and hoping that you figure it out. And so if you do A complement, you get all of the elements here in B minus A, but also out here and here and here and here. Everything A complement is defined to be, let's turn this back to black because it looks better, is defined to be precisely, give me a second, is equal to U minus A. This is the definition of A complement. And so you can see it very much so depends on you. And so here, what is our universe? Our universe is just the people in this picture. I know there's more to the cast. You know, I'm a big fan of Tina Fey, but she did not make this picture that I found on Google Images, so she does not count for our examples. So if you take the complement of the plastics, everyone who's not a plastic, we get a new character. Exciting. We get Pretty Boy, whose name I could not tell you. I saw the movie yesterday, and I can't tell you the name of the actor or the character, but this is what you need to know, is that he's a pretty boy kind of love interest in the movie. You know, you have a teen girl protagonist, you have to have some love interest somewhere. And so the complement of the plastics is the union of pretty boy, goth, and irrelevant. The complement of the art nerds is old plastics, and then you add in Pretty Boy. And so Pretty Boy is really existing in these complements. And just a note, because it's worth knowing, it's spelled like this, with an E, not like I, like you're saying something nice, like this. And that's the complement operation. And usually when you're doing something with complements involved, usually all the sets you're talking about are subsets of U. So for example, if I'm writing A complement and then I write B complement, it's always assumed that A and B are subsets of your universal set U. And so another thing we can write off the bat is that A intersect B complement. What would this be? This would be all the elements in A, but not in B. And so what is that? That is exactly equal to A minus B. And you get a lot of relations with the complement already. You also get a relation. This is something you can check on your own. You get that. Ooh, that was weird. What did I just do? Let's just refresh this page because it is freaking out on me. Okay, better. Let's go back here. Yeah. If you do A union B complement, what do you get? You get exactly A complement intersect B complement. And the way to prove this, to think about this, is that, well, I'll let you think about this. I don't want to spend too much time on too many of these operations. We have a lot of things to go over, especially in set building, a lot of stuff to go over. So I'll let you try to prove this if you want to. I think it's a good problem. You can prove it pictorially, looking over here. I'm going to make some room for the next stuff to come. So the next operation's rather different. It says, moving these around, this is set comprehension. Now this is very different. This is how you define a subset of A, and you define it by giving some sort of property of the elements. And the thing is, you can give any property here. And so the example I'm going to give is we're going to do the subset X in, we'll call it the cast of Mean Girls. And we're going to say X dated pretty boy. And we'll write this. Not perfectly written, but here we go. X dated pretty boy. Let's make it a little smaller so it's easier to see. And this set is exactly Queen Bee and Lindsay Lohan. Now Queen Bee, she looks kind of mean, a little intense, and this is our protagonist. And so you get a little conflict because Queen Bee used to date Pretty Boy. Ooh, where the fuck am I going? Queen Bee used to date Pretty Boy, but now Lindsay Lohan is interested, and they're going to date? Gasp, trauma. What happens? You're gonna have to watch the movie to find out. I can't be all of your cultural education. But if you define this subset of the cast as X dated pretty boy, you will get exactly the set. And this is how you write a general set of Lindsay Lohan and Queen Bee is what this set is. And the interesting thing is you can be extremely general. You can put almost any condition inside of the P when you're defining a subset of A, but not every condition works. The challenge that I was thinking of is that it's a very subtle detail. If you already know this trick, this logic trick, don't answer it in the comments, because if you already know this logic trick, you probably don't need this movie. Not this movie. You still need this movie, whoever you are, but you probably don't need this video. But my challenge in the comments is to give an example of some property that you can't take a subset of X by putting this property in there. It's one of those things like Russell's paradox or one of those diagonal paradoxes that gives you a condition that you can't use. But in practice, they're hard to come up with and they don't come up often. And so any condition you can think of will work here with very, very few exceptions. Now the last thing to talk about is symmetric difference. Now this is an odd one. You can define symmetric difference like this. A / capital delta B is equal to A minus B union B minus A. So you can see how it's kind of a symmetric difference. You have these two differences and then you take their union. And so what does that give you? Well, first you have A minus B, which is this part, and then you have B minus A, which is this part. Oops, so you gotta be careful when you're doing your picture proofs to make sure you don't get any of the intersections. So if you look at this picture, you'll also notice another way to write this is as, now let's get inside the dollar sign. Is equal to A union B minus A intersect B. Ooh. Is another way to write this. And what's special about symmetric difference is it kind of works like addition. I mean, a lot of these have analogies. Like you can think of union as a type of addition. You can think of intersect as a type of product. There are ways to make this formal. There are lots of relations, like intersection distributes over union, which makes it product-like. But an interesting thing about symmetric difference is that A / delta, you have this associativity. You first have this commutativity, delta A. Actually, associativity works for every single operation I've talked about today that involves two sets. So not so special. And commutativity even works for union and intersection. So maybe this is not a very special property. But you also have A delta B delta C is well defined because this operation is associative. But an interesting thing is that if you do A delta A, you always get the empty set. Now this is one that I have not talked about yet, but the way to think about this is you can think of A union B minus A intersect, right, A union A minus A intersect A, and what do you get? You get the empty set. The difference with itself is the set containing no elements, containing no cast members of Mean Girls. Ugh, what a terrible set. That there's this symbol, which is used for the empty set, also important to know, is the unique set in all mathematics that contains no elements. Empty set equals this. There's no elements in it. There's only one set with no elements, and if you take the symmetric difference of something with itself, you get the empty set.